All right, here we are. Welcome to the session on building and operating high-performance MarkLogic apps. We've got a couple of fantastic speakers here. And hopefully you'll get all your questions answered. I do ask you speakers would like you to save your questions till the end. I'll be running around with the microphone. Please do wait to ask your question into the mic because sometimes A, it's hard to hear, and B, we are recording these sessions. So let everyone who's listening to the recording later benefit from the question you ask because invariably someone else will have the same one. So without further ado, I will turn it over to Clip and Aaron.
Thank you, Alicia. It's afternoon, right? Good afternoon, everyone. James Clippinger from MarkLogic, and I'm here to present today about high-performance applications and how to do fun, cool stuff with MarkLogic really fast and really awesome. Looking up at this slide, you may say, why am I hearing from someone whose title is Strategic Accounts? I do a lot of different things at MarkLogic, and one of the things I do is run our global field performance team. I also run our sizing team that works with customers and prospects to understand how to build systems and come up with hardware recommendations. I've been with MarkLogic a little over 10 years. I've worked with a wide variety of our customers, including a number of people in this room. And so I talk to people, I see what's going on in the field. I'm our eyes and ears on the street, I guess, when it comes to performance, odd as that sounds. And my co-presenter, Aaron, I'll let you describe who you are.
Sure. Thank you. So my name is Aaron Miller. I am the manager of performance engineering, and my team is based out of San Carlos. Before that, I was in services and worked with many of our customers and have a long history in both customer-facing roles and pre-sales and technical support, and so very familiar with that kind of wide range of various performance challenges that can come up. So I'm gonna kick things off by just talking a little bit about kind of background, generally speaking, how MarkLogic works, and then I have a fairly simple use case to go into, and then Clip will dive into some other use cases. So I just want to start here, which is the point at which you've written your application, you're in production, something's wrong, nobody knows what it is, and now you're trying to figure it out and diagnose it. And this is kind of where you don't want to be. You don't want to be in production, chasing your tail, trying to figure out what's wrong. In this case, it's like, okay, I took the whole thing apart, and it turns out the problem is someone took it apart. And it's, it's kind of like, did I do that? What's going on? So trying to be a little bit more proactive than this. So how can you be successful with MarkLogic? What's the key to successful performance? So it starts with development, understanding how this product works. When you're writing code, what is happening? What demands are you making upon your system? I have this, this idea about agile development. Not everybody is an agile shop with a capital A, but that doesn't mean that you have to leave all of your performance testing until the very end of your release cycle either. So if you are a capital A agile shop, you can integrate performance testing into your dev cycles. If you aren't, you don't have to leave it till the end. You can still integrate it so it's an iterative process. Finally, when you get to production, there will probably always be firefights. You're always going to be in some situation where there's a hardware failure, software failure, user doing something that you didn't expect. So when you get into that situation, what's the methodology that you can use to get yourself out of it? All right, so I want to start a little bit with understanding MarkLogic Server. This diagram is from a white paper which is available on our developer site. So the white paper kind of goes into detail about how we use various system resources. This is a very high-level diagram about, the various components that make up the server and the different system resources that these components might use. And so you see on top what I would call our E-node or our evaluator node, where queries are handled and the tokenizer happens, and you've got CPU, memory, network. On the bottom is where the data lives, so that's your D node, your distributed caches, and some of the data-based operations. So I'm going to talk about ingest and query. These things usually happen together. It's very rare that you're just dumping data into a database and not actually asking any questions. So I'll just talk briefly about what's special about our ingest process. Then we'll shift gears and talk about queries. So what happens when you do XDMP document insert, or using your Java client or your Node.js client, you're inserting content. So first, the document is loaded into an in-memory stand. That's obviously an in-memory structure. Documents get loaded into this structure, in-memory structure. And at the same time, the transaction is written to our on-disk journal. So it's just like any database journaling system in that if the machine were to crash, or something happened in the process before that in-memory stand was written to disk, we could replay the transactions. Periodically, we do what's called a checkpoint, where that in-memory structure gets written out to disk. So you have a big write out to disk. We go to the journal, we say, okay, we wrote out all the transactions up to this point, and you start the whole thing over again. And at the same time, there's a process going on in the background called merging, and so we'll talk about that a little bit too. So what are your resource costs? When you're writing your code and you write XDMP document insert, what are you actually doing here? So you're going to have your merges. They'll show up as background I/O. So on Linux, they'll show up as nice, your nice percentage. You're going to have CPU costs because you're indexing the content as you're inserting it. So you are going through the process of creating those indexes. You also have merges going on. Those will use CPU too, but they'll be background I/O. If you're doing transformations, you might have some fairly complex transformations that you're doing as you ingest the content that will use CPU. And you have memory, and we'll talk a little bit about the caches later, but you're going to be loading data into these caches. Just calling out this one item, preload mapped data. And so this is a setting that we'll come back to. Remember this. Clip will talk more about the implications of this. But if this is set to true, basically what happens is all of your memory map file data pages load at the end of the merge. So you have this big load process right at the very end. You also have network impact if you've got a big distributed cluster sending data around from node to node. What are these merges anyway? What happens in a merge is we combine these on-disk stands, and we do this to optimize the indexes and also to reclaim disk space. And it's something that happens, it's going to be running in the background. Whenever you do updates in your application via either ingest or updates, you'll be seeing merges running. Couple of things to keep in mind with merges. The big thing is storage. So because we're combining multiple stands and reclaiming disk space, you're going to actually need extra disk space to handle merges. And so at this point, generally about 1.5x your index data is a good rule of thumb. If you want to get more specific about it, for each forest, it's the total index forest size plus 64 gig per forest, and that's based on the max merge size. That number is going to change in 9.0, so something to keep in mind there. If you are doing HA, or you're doing, it should say disaster recovery actually, DR or HA, and you're doing database replication, that's something to think about in terms of storage. What if your primary site is unavailable, or your backup site is unavailable? You're generating all these transactions that will need to be shipped to the backup later. All of a sudden, your disk storage is growing quite a bit. And for database restores, we're actually copying the data to a temporary location. So you need 2x when you're doing the restores. Finally, in general, what to expect in terms of IOPS when all of this stuff is going on, you're going to have this big spiky write when we write out that in-memory stand to disk. We do sequential writes. You're also going to have the journal writes. And these are always greater than or equal to 512K. So let's get into the query side of things. Let's talk a little bit about some of our important details on querying. So when we when you run a search, and assuming that everyone to some degree will be running a search, even if you're just using this as a transactional database, you're still going to want to find stuff. So I don't know, how many people were at Mary's talk yesterday about search? Okay, cool. So I'm not going to go too far into the details here, but the basic idea is that we first try to resolve the query from the indexes. And the indexes are in memory, so that's going to be fast. And then if you then take this second optional step of filtering, we actually open up each document, check to make sure that there is this match, and then say, yes, indeed, this is correct, this is the right match. So filtering is this optional step, and what Mary talked about was this is kind of the equivalent of hiking the Pacific Coast Trail. So this is the walking to Seattle step right here. If you are trying to figure out what's going on with your performance, you may be unintentionally filtering your queries, which can cause quite a lot of I/O overhead. So this is something that you want to be very intentional about. There may be times when you want to do this, but you just want to be really clear about when you're making that choice. In general, if possible, it's great to align your queries with your indexes. So if you need phrases, for instance, like this case, you could turn on fast phrase search, and that would be much more efficient. So how do you know that you've got all of these filtered queries running in production? You're starting to see problems. You have a whole lot of long-running queries. You might see this kind of pattern. We have a monitoring dashboard and a monitoring history. It's at the host name port 8000/dashboard. And so there you'll be able to see some real-time stats about what's going on. Again, I'm not saying never use filtering. I'm saying if you know you need to walk to Seattle, then by all means do it. However, if you can tune your indexes to match your queries, that's going to be much more efficient for you. And I would say only use filtering if you expect that you would have false positives and your application can't tolerate that. So let's talk a little bit quickly about distributed caches and what this means. So basically, what this diagram is showing you is that our caches also live with the data. So you've got a distributed system, you've got lots of these forests, and all of these caches and indexes live with the forests. They are where the forests are. So we have a number of different caches. There's the list cache, and some of you may be familiar with these various caches based on different error messages that you've seen from time to time, with these caches filling up or not being able to insert content into these caches. So list cache is your term list. Compressed tree cache is our compressed, in Mary's talk, it was the microfiche. It was like the very compressed version of documents. That's going to be on your D nodes, or where your data cache. The expanded tree cache is the expanded document. That's going to be on your evaluator node that returns to the calling client. We also have triples and a triple value cache. Those are with the D nodes. And we have some memory map files, range indexes and lexicons, memory map files that are pinned in memory. So how can you make the best use of your caches? Well, generally, these caches get optimized at install time. So when you install MarkLogic, we'll look at the available system memory and make decisions about the cache sizes. At that point, you might say, oh, well, I want to tune my caches. I want to make things better. It's always a good idea to check with support before you change any of these cache settings, because they can have pretty dramatic performance changes with your application. So if you add memory, yes, you would need to increase your cache sizes, because this is something that we do at install time. If you are separating E and D nodes, then again, you want to look at your cache sizes. Your compressed tree cache should be bigger on D nodes, and your expanded tree cache should be bigger on E nodes. However, don't forget about reindexing. When you reindex, you're going to need to use some of that expanded tree cache on your D nodes, so you don't want to set it to nothing. So with all of that background, now I'm going to shift gears and talk about a simple case study and how you might go through the process when you're writing your code of trying to understand the performance characteristics and what might be happening. So this is a very simple use case. This is going to be, you think, okay, I have all this content coming into my database. Once a minute, I want to update a file. And I have these 4 different types of content: news, tweets, stock prices, articles, and I want to classify them and update with numbers. So here's a screenshot of our query console. This is maybe my first attempt. I'm new to MarkLogic. I'm trying to figure this thing out. So I want to count each one of these document types. And in this case, I'm just doing a word search. I'm just searching tweets, news, articles, prices, and then we're getting the count of each one of those data sets. So at this point, things aren't working out too well. I start profiling. So this profile tab is in Query Console. You can also write your own profiling application with PROF report, so prof report. And that will output the info to your log. So you start profiling, and it's like, oh yeah, filtered searches. I remember that, walking to Seattle. So at this point, we can change the CTS search call to unfiltered, and things get a lot better. But at that point, we hit our next bottleneck. So now we do the profile again, and now the count is taking a long time. So it's like, okay, yes, what can I do instead of this count? There's a function XTMP Estimate that uses the indexes to provide those sorts of counts, so you can use that. And at that point, you actually don't need the unfiltered keyword anymore, because that is by default unfiltered. So great, okay, I've worked through my performance problems in dev. Now I'm gonna go to scale and see how things look in my load test. So everything's working great in dev at this point, but when I try to run it at scale, everything starts to slow down. Transactions are taking a really long time. The application performance is terrible. And so my application, one of the things that it does is just updates these counts in this config document. So what's wrong here? So let's take a look at the monitoring dashboard to try to understand, when I'm running my load test, what's going on. And as you can see here, there's a lock hold read. So it shows you the amount of time that locks are held and also the number of locks that are being held. And all of a sudden, look at all these, I have 500,000 locks almost. What could be happening? So I'm only doing one document update. Why do I have 500,000 documents that are locked? So whenever you're in the context of an update transaction, every doc that you reference in that code module, be it server-side JavaScript or xQuery, will be locked for update, because we don't actually know, the server doesn't know which document you're going to update out of all of this. So the query optimizer is trying to figure it out. We're just going to lock everything. So, you know, in your module or in your code, you might have a statement that is just doing searches and pulling data out. You don't actually intend to update those results, but you're using it as part of your logic, and you're inadvertently locking all this data. So you can to fix this, you just do it in a separate transaction. So that's one solution. The other thing to think about here is just to be intentional about when you're doing updates versus queries. So you can use this declare option, XTMP update true, for when you know that you're going to do updates. You can also add an assertion. So this XTMP request timestamp will be empty unless will be empty if it's a query. So that is another way to kind of get a handle on this. So what else could you do? Well, what if instead of doing just this random word search, what if we put this into an element? Well, that's great, but then you're still doing this element search. You have to think about all your caches. There's a cost associated with that search. Much better solution here would be to use collections. So collections, you could categorize the documents that way. And collections, there's a collection lexicon, which is essentially just another range index. So that is also pinned in memory. So you get the benefit. You also don't have to add custom code. You can use like this MLCP option, output collections, and MLCP is our content pump, so it's a Java command line tool that you can use to ingest. Or the best solution would be to use the envelope pattern and our canonical format. And I don't know if anybody's seen the Data Hub presentations that have been going on, but there's tons of great info there. So one last thing, SQL and semantics. So if you're doing SQL and semantics, everything is a little bit different. It's not quite so, it's not going to be document-based in the same way. And so the most important thing there is going to be having enough memory. So, you know, the SQL and semantics workloads are analytics workloads. They're going to be heavy on memory, particularly in-memory joins. So if you have one of these applications, you generally do want to separate the E and D nodes. And you also want to make sure that you're running E nodes that have at least 64 gig of RAM, because these are very memory intensive. There's going to be a semantics workshop actually right after this one, so there'll be a lot more details here, but there's lots of diagnostic events that you can turn on related to Sparkle. You can see what cost analysis is, what the execution path looks like, and finally, if you see a lot of these mem canceled, we, in our query plan and our query optimizer, will check to see how much memory we think a query will use. If it's going to vastly exceed your resources, we'll cancel the query. So that might be another reason that you'd see that. So use meters or monitoring tools to understand what's going on. Cache, locks, CPU, disk, memory, combination of system tools and our tools to see what's going on. And be intentional about your code, transformations, transactions, updates, filtered results. And finally, make sure you separate the analytical workloads from the rest of your application by separating E and D nodes. And with that, I will turn things over to Clip to talk about some recent trends.
Thank you, Aaron.
You're very welcome.
So Aaron just gave you an excellent overview of sort of the system level tuning of MarkLogic and how to think about these things. And I'm here to talk to you about what we see in the field and really recent trends and what we see as performance issues at customers. And some of the big themes are how you can use the tools that are in MarkLogic. So the historical meters are an incredibly powerful tool. I'd advise anyone interested in performance to really study how meters works, see all the information that's there, be aware that there's a lot of ways you can drill down into the information, but also be aware that you can export the data into Excel and you can do a lot of analytics in Excel to figure out what's going on. And Excel, as much as we all kind of detest it, it's a great analytics tool. So please keep that in mind. But also keep in mind that you need to look at your monitoring in context. Meters is your best friend, but like a good best friend, it's not going to tell you how to live your life. It's just going to give you information and feedback on what you should do with your life. And because of that, you need to know what your system should be doing, and you need to know if what you're asking the system to do is reasonable. We do sometimes get requests from customers for things where my argument back is we would have to go faster than the speed of light for MarkLogic to be able to do that. And while our engineers are working day and night to make that happen, it's not going to happen. You also need to keep in mind when you're looking at resources, this is sort of the order from most problematic resources at customers to least problematic. And the very most problematic resource is disk bandwidth. Disk bandwidth starvation is the biggest problem customers have. And it's something that can be planned for, it's something that can be estimated well. You just need to make sure you actually have the disk bandwidth available. Next up is RAM capacity, having enough physical memory so you're not swapping, having enough physical memory to run your queries, having enough physical memory for your range indexes. And then the other three, there are issues at various customers. I'm looking around this room, I see people I've worked with on each of these resources, but they're not huge issues most places. In particular, disk capacity, at times disk capacity can be a real crisis, but we all know how to fix disk capacity issues. We either use less disk space or get more disk space. A couple of other things I mentioned though, and this is why it's important to work with MarkLogic support when you're seeing performance issues that don't make sense, is we've had a couple of issues this year related to operating system bugs or MarkLogic bugs that turned out to manifest themselves as poor performance. It's a very rare thing. It's not something you should plan for, but that's why you should work with our team to investigate any performance issue you're seeing that doesn't make sense, because you may be coming into something where there's an actual Red Hat OS bug that's a known issue with the OS, or perhaps a known issue with MarkLogic. The other thing, we always want as much speed as possible, but keep in mind speed always costs money. Whatever resources you're using, whatever code choices you're making, there is a cost. And think about those costs as you're developing, for the developers in the room. Think about those costs as you're working with developers, the DBAs in the room. And in particular, if you're making decisions about indexing, every index you enable, whether it's a range index, whether it's the case-sensitive index, if it's one of the wildcard indexes, if it's the triple index, as you enable that, make sure you're getting business value out of enabling that index. Don't just turn it on because it's there and it looks cool and geez, we might want to do case-sensitive searches someday. Make sure there's a business case for it, because every index you enable will have a cost at some level. Finally, load testing. We are starting really this year pushing customers to think about load testing from day one. Think about how you're going to test your application, because that's the very best way to reduce your performance risk. I can estimate your resource consumption, but it's way better if you estimate it based on your actual workloads, your actual application, your actual data, because that's going to change the resource picture. We can come up with some level of estimates, but there's going to be nothing like actual load testing data. And if you can push the load until you find your bottleneck, then you know when your system has a bottleneck. It's a wonderful thing. Knowing where the bottleneck is the whole point of performance analysis. So think in terms of how can I push my system to the point where it will break. I'm going to run through a few recent performance cases. These are in no way representative. They're mostly chosen for entertainment value, but we'll go through these and see what's there. So first we have a case of intermittent slowness. So in this case, the system was not meeting its SLAs for a few minutes at the start of each hour. At the top of the hour, there were a few minutes where it was just slow. And meters showed that the CPU was maxed out with high I/O weight during these windows. So this was mysterious to the customer. They weren't sure why their system got slow at the top of every hour. And it turns out there was an external system that made a whole lot of queries in one huge flurry right at the top of the hour to update some data it had. And the folks running this system, they were sort of vaguely aware these queries were happening, but they were not aware of the sheer volume. So they didn't know what was coming in, and they weren't aware that this was causing a resource crunch for them. It turned out having the downstream system spread out those queries, no big deal. They were happy to do it. It took care of the performance issue, problem solved. But then here's a case where you have general slow queries. So everything looks normal, but queries are slower than expected. Disk usage is reasonable, low user CPU. There's a little I/O weight, but not a lot. And there's no swapping. So there's nothing apparent about why queries should be slow, but they are slow. And the issue here was very high per query disk bandwidth. When we took a look at the meters data and took a look at the request rate and divided the total query disk usage rate by the request rate, even though the query disk traffic rate wasn't very high, when you divide it out, every query was taking 5 megabytes of disk bandwidth. So 5 megabytes of disk bandwidth in a large cluster, that's going to take a while just to happen to get the random reads, get everything set up. So this is a case where we were able to tune the queries, reduce their disk footprint per query, and significantly speed up the system. Then we had a case where this was a customer on AWS, larger AWS instances, and we saw very high system CPU utilization and low user CPU utilization under load testing. So the system was not performing the way they were expecting it to. We have this system, we all know system CPU exists. We're a little fuzzy on exactly what it means, but we know it's there. And they were running hot on system CPU, not getting the performance they were expecting to. And the reason for this was a bug. This was a bug in MarkLogic that was related to how MarkLogic was allocating memory. It's since been fixed. If you're on the latest release of either MarkLogic 8 or MarkLogic 7, or MarkLogic 9 for that matter, you have this fix in your hands. But this manifested itself in a pretty nasty way, and we worked with the customer to find it and figure out what was going on. And so that's where calling in support can be your very best move from a performance perspective, because this was a customer with a lot of experience with MarkLogic. They knew that something was up with their performance in AWS compared to other environments, and they were able to point it out, and we were able to help them fix it. So another customer, given everything else going on in their system, their memory utilization was very high. Eventually, this led them to swapping. And the one major memory setting that stuck out was the caches were configured to the default values. So they hadn't over-allocated caches. They hadn't under-allocated caches either, but there were no crazy high cache values floating around. And this turned out to be caused by the URI Lexicon. I love the URI Lexicon. If meters is my best friend, URI Lexicon would at least be in my wedding party. But the URI Lexicon is a range index, like any other range index, and a string range index will store every unique string in that range index in memory. So if you have the URI Lexicon, URIs are unique because they uniquely identify documents. They can be very long. In this case, they were, I think, on average 200 characters long, and those are all getting stuffed into memory. So if you're using the URI Lexicon, which once again, in my wedding party, I'm a big fan, do keep in mind that it's putting everything in RAM, and that could be driving your memory usage. And it may make sense to either use short URIs and use some other element as a descriptive value. Maybe if you're using directories, consider using collections, because collections work the same as directories, but they don't need to be stuffed into the URI. Or just reevaluate how you're approaching these sorts of problems, and whether you really need the URI Lexicon, which, once again, big fan. So we had another system. This was a high-volume production system. It was meeting all of its SLAs, and this is actually a case that happens fairly often at customers. Everything's great, and then the DBA runs a report in Query Console after a bunch of data was loaded overnight. And the system just grinds to a halt. Well, the report is running, response times get very bad. The report finally ends, everything is great again, but it seems like this one report is doomed and just ruins the whole system. And that's direct language from a customer who experienced this. And this is one that Aaron set up earlier, because we're big believers in foreshadowing at MarkLogic. Preload was disabled. So preload is a setting at the database level that determines whether memory mapped structures, specifically range indexes, are loaded at the time the stand is mounted. So if preload is enabled, when you load your forest or when you load a new stand after it's been created by merge, it actually loads all the range indexes into memory. If preload is disabled, which is the default, it doesn't load the range indexes. The range indexes are loaded on demand as each one is called for. So what had happened with this customer is their main application was running along just fine and using range indexes as all the merging was taking place from the ingest activity. So there were a whole bunch of large new stands that had been created by merge activity, but it wasn't really noticeable with the main application because it kept calling in the normal range indexes. But then this report called a range index that hadn't been hit until before the data load had started. So all of these range indexes got loaded from disk, and the query needed the range indexes to be loaded from disk to be completed, and the disk demands are what caused the rest of the system to slow down. Because loading range indexes is really high priority, it's high priority. It takes precedence over a lot of other things. So in a high-performance application, I would recommend enabling preload. It does mean your forests will take longer to load initially, but it's really a price you're paying to load the range indexes early rather than on demand. And loading them on demand might make sense in some cases, but it's usually only makes sense if you're not actually using your range indexes, which if you're not using your range indexes, why do you have a range index? They're in memory. They're pretty expensive. So that's it for cases we've dealt with, and oh, we have a question, all right. Yeah, we're going to get Alicia running around with the microphone, and please do wait because we are recording. So,
thank you. I have three questions basically. The first one is a MarkLogic recommendation is for running MLCP on another machine from where the database is. But can there be scenarios where it is advisable to run on the same machine? Because if you're running on a separate machine, the network traffic will be involved. That is the first question. The second one is about...
Why don't we do them
Why
one
don't
at a
we
time?
start
Yeah. Do you want to answer technically, and then
Okay.
Sure.
I'll give my spin?
So it would be very unusual to have network be the bottleneck in that particular case. While it's true that running it on a separate machine means that, yes, you need to do a network hop, at the same time, you're also going to be using CPU and memory to go through the process of loading the content from disk in particular. There's quite a bit of I/O. If you run it on the same host as a server, you're going to be competing for those resources. So generally speaking, within our own performance testing lab, we never run them on the same host, because generally speaking, you don't want to be competing for resources in that way. And generally, the network cost of sending the data over the wire is much less than the CPU, I/O, memory resources.
Okay.
And the one thing I would add on a business level is, because most customers license MarkLogic by the core, the other thing is, if you're running MLCP on the same host, you're using your licensed cores to run MLCP, which isn't normally required. So.
Okay. The second question is about the fast load, and one of the reasons why it is not recommended is because it bypasses the E node and goes to the D node. So if you have a cluster, then there will be issues of data discrepancy. So what about a scenario where you have only one node? Maybe you have a cluster, then can that be used, or can there be other problems with fast load?
So it's not that fast load isn't recommended. It would be problematic if your forest topology were to change. So if you're loading content and you want to bring on new nodes and add new forests, then yes, that would be problematic. In general, bypassing the E node, if you've got a distributed cluster and you want to bypass the E node and go right to the D node, that will be faster, and that's a benefit. So if you can use it, definitely do. If you've got a single node, you're still going through the E node. The E and D node in that case are shared. You're still you're still dealing with the E node part of the process. The application server will then send it off to the correct forest. So there's still a cost. It should be pretty minimal if you're just talking about one node. So
and that's single node fast load. I think we've tested it, and there's a tiny
very
benefit.
small difference.
So
Yeah.
Okay. And finally, about the question of running like different jobs. So is it possible if we can prioritize, like there are maybe 3 jobs, and we can say, okay, if this request is coming from CIO, maybe should run at the highest priority versus some
jobs meaning like database requests, or
like a database, like let's say there are 3 queries, or maybe we have a query coming from an application versus like some tester testing on, I'm just thinking aloud, like, can we have some kind of a resource governance?
So the best method for managing that is to manage the thread pool for different app servers. So you might have many customers have like their main application app server that has lots and lots of threads, and then like a batch app server that has maybe 2 or 3 threads for running long-running jobs that should run in the background and not take resources from other things.
I mean, not at the database level yet. I mean, we cannot do that at the database level, that if we receive...
There's not currently a way to prioritize that way at the database level.
So using the app servers is definitely the way to do it.
You can manage it in the aggregate, but you can't say this is an express lane versus this is the,
Right.
We will let other rows ask questions.
So just a question on the E node, D node things. So like, when should we go for E nodes? Like, is there a limit on number?
Yeah,
that's a religious question,
It
really.
is. So, I mean, we have some customers with clusters bigger than 100 who are running shared E and D nodes. So we also have customers with clusters that big that have them separated out. In some ways, I would say if you're running Semantics or SQL, you should separate them, because you want to allocate things properly for those analytical workloads. You want to try to separate those analytical workloads. In other cases, a lot depends upon your hardware, your application, and I would say there's no hard and fast rule about when to separate versus when not to at this point.
And from a field perspective, the vast majority of customers run combined DE nodes these days, but it's very handy sometimes being able to split them out either for things like SQL and Sparkle, or if it makes sense from a caching level, because sometimes it makes sense to have a small number of E nodes which have lots of their cache loaded up, servicing a very large number of D nodes.
Is there a way to know exactly how much memory or RAM is being used for each cache in the cluster?
For each cache in the cluster?
Yeah, say for example, list cache, I have allocated say 32 GB, but I
Yeah.
want to know
Yeah.
how much actually I'm using it, or say for range index, how much I'm using it currently, so that I can size it accordingly for the future.
Yep, yep.
Yeah, I mean, the way the caches work is they're allocated in full. So there's not a way of knowing how much you're using of it. You can keep track of list cache hits and misses, which will tell you sort of how much efficiency you're getting out of it. But I don't think there's a concept of cache fullness, right?
Yeah, so that's mostly true.
Oh man.
The one case that's different is the triples cache and the triples value cache. So those are not, all of you, as Clip was saying, like they're allocated. When you start the server up, it's like, okay, your list cache is set to 16 gig. 16 gig is being used for your list cache. Whether or not it's full, whether or not you've got a good hit miss is not, not part of that equation. For the triples and triples value caches, those grow and shrink. So, those should be a little bit more obvious. I think probably the best way to tell what your utilization looks like, there's a built-in API called XDMP cache status. And that is expensive, so you don't want to necessarily start running this hundreds of times in your production environment, but that will look at each partition in your caches and tell you what the ratio is, how much of it is what's free and what's busy. And so if you do that and you're looking at it and it's like, oh, look, 75% of it is free and has been since I started the server 3 weeks ago, then yeah, maybe, you don't need to worry about, you can look at decreasing that. So, but in general, again, I would not recommend messing with the cache sizes or partitions without talking to our support team to validate it.
Yeah, customers have gotten in a lot of trouble micromanaging their caches.
Yeah, it's easy to hurt yourself. We
for
don't want you to hurt yourself.
Sorry. For cache, I can use that XMP cache trace, but for range index or URI Lexicon, how do I know how much, what's my hit and miss range?
The range indexes are a little bit different. I can't recall if they're part of cache status.
So
I don't think so.
they're not. So actually, forest status will tell you the in-memory size of each forest, and that includes the range indexes. So that gives you an aggregate number. You can also, if you're feeling adventuresome, look in the forest directory itself and see the actual range index files. And since those are loaded completely from disk, that gives you some sense of what the range index sizes are. Forest status. So the forest status page or getting the forest status from the admin API, the various ways of getting forest status, yeah.
Hi there. I was wondering if there's a way to look at the queries running real time. I think query meters, does that have to be run like at the command line with a query? Would there be a way to do that to see what's running, consuming, the most resources, per se?
So queries that are currently running show up in the app server status pages or the task server status page. Are there anywhere else?
Yeah,
I
the
think.
monitoring dashboard. So if
Yeah,
you look at the monitoring
there too.
dashboard, it'll show you 5 longest running queries. So there's a few different dashboards that you can use to look and see what's running. That's probably the easiest or fastest way to see.
And if you have debug enabled on the app server, you can do a stack trace on the running query, which can be very handy sometimes. Wait,
Hang on.
we need a
Hold her up the
microphone.
microphone.
We don't rank the soft microphone they toss around to people, which is
You
probably just
provide
as
some
well.
use cases, and then you find out what the problem is and provide solution. What is the step that you go to when you go to a customer site? What is the step you're looking for the most?
Well, Aaron, you can answer this one. I mean, that's, yeah. No, the, you know, I mean, I always look at as you're sort of an emergency room doctor, and the first thing you need to check is the basics. You need to make sure you're not swapping. If you're swapping, you're gonna have a bad time. There's no way around it. Checking disk bandwidth, checking disk space, you know, and that's the advantage of MarkLogic is you can look at a log file and usually there will be something in blinking bright lights if there's something truly bad going on. But then it's finding out what the symptoms are. You know, walking through these cases today, you can see that it's often something weird happens occasionally or something a little weird happens all the time. And then it's just tracing through the resource picture and understanding what the resources are. And going back to the earlier slide too, remember disk bandwidth is the most common problem. So that's always the first suspect. In part because the next most common problem is RAM, and since we've established we're not swapping, we know it's not RAM, or at least we're pretty sure it's not RAM.
I would also add to that to not neglect your error log,
Yeah.
which I often forget to do. I recently had a problem where I was trying to understand, I had a performance test. This test was not running the way it should have been running. I was like, what could be going on? I was going through all my SAR data, all my DStat data. I was looking, I was like, it's using more resources on this one host, and it's like, oh, when I went and looked at the error log, one of the replicated forests had failed over, and so that host happened to be hosting more data, and it's like, I should have looked at the log. Yeah. So starting with your error log is always a good.
We have a lot of error, so you can using different tools like Splunk to just searching your error to looking for. Is that MarkLogic had that capability that we can just using other external tool and doing that?
And I mean, I use grep for that. I just have a bunch of key phrases I search for, depending on what the problem is. Or Splunk. If a customer has Splunk, we use that because it gives you a nice cohesive view. But yeah, there's nothing in MarkLogic specifically for searching the logs.
So in the monitoring dashboard, you can see the top 5 queries are running at that point of time. That is captured only if you actually open the monitoring console and keep it open ready. And that uses a JavaScript object to actually capture or calculate the top 5 queries. Is there a way that you can capture that information without opening the monitoring dashboard in the meters database?
So I think you'd have to have written application logging that would give you the query output. And query, there's an XDMP elapsed time, which is super lightweight. You could use that to just be logging your queries out to your application log and logging the elapsed times there.
Yeah.
That's probably your best. Your best bet.
Or we do have a community project called Service Metrics, which is a framework for getting metrics on queries as they're running. The caveat there is keep in mind that there's no way for a query to time how long the update phase takes after the query's run, because it's after the query's run. There's no way to do it. So that's where we often turn to application side logging to see how long those are taking.
One other thing about that too is thinking about our whole development lifecycle. XDMP plan is another built-in, and it will give you a query plan, so you can get a sense of what's going to happen before you actually execute your queries. So when you're looking at, switching over from your dev environment to UAT or to your QA environment, definitely a great idea to take some of your queries and run plan to see what the impact's going to be at scale.
Got it.
I learned that you do have some sort of trending the metadata. Data, raw data, both the live that are also the history. Is that it's a way that you have provide like some sort of API that we can just generate a report and look at the trending.
I mean, I think you can access all the meters data through an API.
Oh, absolutely.
Yeah.
Yeah. So the monitoring dashboard that we ship with all runs off of. We're basically collecting this metering data. The monitoring dashboard is an application that's running off the meters, the metering data. It's making REST API calls, and we haven't talked a lot about REST today, but you're making REST calls. REST is built on top of this whole framework. So you can be making REST calls to get whatever you wanted.
Yeah.
There's also ways to create custom graphs on that page, and I think we've got, I think Mike did a really good blog post about how to create your own graphs. We're also always adding metrics to that. So you can have a label that you've got your performance test, here's what it looked like, here's all of my data, all of my trends, I can go back and look at it.
All right. Well, that's all the time we have for today. Thank you both for a fantastic presentation.
Thank you all.
Great questions from everyone.